So last class we were discussing something on the concordant pairs or discordant pairs, right? So concordant pairs means just imagine the scenario. If let's say I have, we'll take a simple example. Let's say I have a data set of 100 emails. Out of that, 80 are regular emails, 20 are let's say spam, right? So generally in the classification table, what we see, if I have let's say 12, 80 and 20, how many of them are able to correctly predict as correct email? How many of them are correctly predict as that spam, right? So true positive, true negative, then false positive, false negative. Like that, there are four parameters comes into picture. And that is where our precision, accuracy, recall, all those parameters we calculate. How it is different when we talk about these concordant or discordant pairs. If let's say I have 80 regular email and 20 spams, right? 80 means non-spam emails, which ideally should come to my inbox, and 20 emails which are spam, right? How many pairs of emails I have? 80 into 20, that will be 1600 pairs, right? So now what happens when we look into this concordant discordant pairs? So there are all the combination of spam email and non-spam email, right? In any each pair, I have a spam email and non-spam email. So what does this concept of concordant pair tells? Out of the 1600 pairs, right? Or how many pairs you are able to fix a threshold. If I fix a threshold, I'll be able to segregate that spam email and non-spam email, right? Let us try to have a this. When I say threshold is nothing but the probability of being spam or not. Let's say I say that threshold is 0.6. Any email, if I calculate from where that, so the predictors will be different variables like which location that email has come, what is in the subject line, right? Let's say subject line 3 times it has been mentioned offer discount of 80 percentage, like that, right? Or like let's say your this email ID itself is kind of little uh, sketchy, right? You are not sure about that. Like that, there are many predictors of predicting whether email is spam or not. But at the end, what it shows, it doesn't show that whether it is a spam or not. It shows the probability of being that spam. If I put that equation in logistics regression, at the end, it calculates the probability of that email being spam, right? And from our side, from the business side, we put that threshold as 0.6. So any email which is crossing that threshold, let's say 0.62, that will go to the spam folder. Any email which is below that threshold, probability of being spam is less than 60%, it will go below the, or it will come to the inbox. So what does this concordant discordant pair says? If I have these 1600 pairs of emails, spam and non-spam, or how many of them, how many percentage of them I am able to fix a threshold so that I can correctly identify spam and non-spam. So let's say if I fix a threshold of zero point 0.6, one email, spam email, has a, when the algorithm calculates, it calculates 0.63 for non-spam email in the same pair, right? I have a one pair where one email is a spam email, another email is a non-spam email. For the non-spam email, it calculates 0.58, right? In this scenario, what happens? If my predict threshold is 0.60, I'm able to correctly classify the non-spam as non-spam, no, sorry, spam as the spam because it has more probability of being spam, 0.63 or 0.64. If it is 0.58, I'm considering it as a non-spam. So what happens? Correctly, it is able to classify those two emails. But sometimes it might happen, even though if I put a zero point 0.6 as my threshold, for that regular email, the calculation of the probability is coming as 0.68. And for the, let's say your spam, actual spam email, it is coming as 0.64. In that case, what happens? I cannot fix a threshold. Even if I fix a threshold of 0.6, what happens? One which is spam is correctly identifying is being spam, but also the non-spam email for which the probability is being calculated as 0.68 is unfortunately being treated as spam, right? So in this particular scenario, I cannot fix a threshold. I cannot have a probability threshold which will correctly classify these two emails, right? Or it can be some scenario where I fixed a threshold of 0.6 both for the spam and non-spam, your probability also is coming as 0.6. In that case, it is a tired pair, right? So both in that threshold itself, whatever threshold I have fixed, that itself is coming. That probability when I calculate of being spam, exactly same it has come, right? So taking all those 1600 pairs, if I try to see that or how many pairs, how many percentage of pairs I'm able to correctly fix a probability threshold which will correctly identify a spam email and non-spam email. That gives me the percentage concordant pairs, right? For some group of emails, some pair of emails for which I'm not able to correctly identify, that will give me discordant pairs, right? So these are the number of pairs for the data set which I have worked on. So see, this is not the total number of data points is around 40,000 or 38,000, right? It is almost same as the data set I have given you for your class exercise with few changes. But number of pairs, if you see, it is a big number because it has taken the like kind of 1, 0, yes, no, and multiplied by that, right? So that is where number of pairs, if you see, this is a very big number, right? It is a direct correlation or direct relationship with when you talk about this receiver operating characteristics or area under curve, right? This this information which it shows, this area which it shows is nothing but percentage of concordant pairs. Am I able to fix a threshold which will show that okay, these mean percentage? If I see 86.32 percentage model 8, if I go back, this was percentage of concordant. If you go back and look into this statistics 86.3, that is nothing but in my final model, which is the final model after all the iterations I'm able to fix, that itself is 0.8632. That is the area under this curve. That shows the number of concordant pairs, or sorry, not number, percentage of concordant pairs. By fixing my probability threshold, how many pairs of whatever, my yes, no, so basically binary classification, right? Yes, no, 1, 0, whatever I take, I'm able to correctly identify, right? So that is nothing but your area under curve, right? If you randomly pick a random positive or random negative, what is the probability my model ranks them in the correct order? Because in the model at the end, what I'm saying, any email which have a threshold, which have a probability of becoming spam greater than 0.6 will become a spam email, right? So if I'm any two pair of emails, I'm able to correctly predict whether that will go to a spam folder or not spam folder. That gives nothing but my area under curve, right? Gives an aggregate measure of performance aggregated across all possible classification threshold. Why it is important? Because it takes care of all the classification threshold, not only 0.6. It will look into how many classification threshold starting from 0 to 1, because that is the range, right? Maximum probability can be 1, minimum probability can be 0. Any number in between 0 to 1 can be your classification threshold, right? If it crosses that threshold, that will be identified as a event. If it doesn't cross, it will be classified as a not event. If it crosses that limit, it will be classified as a whatever spam. If it doesn't cross that limit, it will be classified as not spam or non-spam, right? So that is where your area under curve is important to understand how much accurately your model can identify any random number of positives and negatives, right? This part, I guess, already you have discussed how to interpret your logistics regression kind of estimates, right? So in case of a continuous variable age, right? If I go to the exponential of my estimate, it shows 1.011, right? If it was a linear regression, what would have told? For each increase in age, the parameter is increasing by 1.001, right? So that was the very simple. But here what I say, for each unit year or whatever the unit of age is given here, increase in that unit, if for everything remaining same, everything else remaining same, each unit increase in age increases the order of whatever we want to predict. Or we wanted to predict, let's say, whether somebody will take, this was for a marketing campaign, right? Whether that person will take a offer or create a account with us, right? Increases by that much, 1.1 percentage, right? This is in percentage terms. If I take baseline is 1, how much improvement in odds is happening, right? So any logistics model we interpret in the improvement in odds rather than increase in the event, right? Because here we are not calculating the continuous variable like linear regression. We are calculating what is the increase in probability. Other way of talking about probability is odds, right? Event happening divided by event not happening, right? So like most of the times this kind of terminology is used in betting, right? What is the odd of, let's say, Virat Kohli hitting a six in next ball, or like having a century in this next match, right? What is the odds? He hitting a century divided by not probability of not hitting a century. That gives the odd, right? In this particular case, a person creating a bank account divided by person not creating a bank account. Probability of person creating account divided by probability of person not creating account. So that is the odd. So that odd increases by 1.1 percentage, right? For each unit increase in age. Again, similarly for the categorical variables, you have to compare with the baseline, whichever you have taken as the baseline. In my data set, which I have removed for the class exercise, what I have given to you, I have removed unknown parameters. So unknown is taken as the baseline, right? So this is where estimate is showing as 0. So when I talk about singles, right? So there are in marital status, there are 4 categories: divorced, married, single, and unknown. If I take, unknown is the baseline. What does the single in comparison to unknown says? A person keeping everything same, if person who is not married, divorced, that person who is a single person, right? In comparison to unknown status, right? That person has a improvement in odds of opening an account with us, or savings account or whatever fixed deposit account, and this is for the bank marketing campaign, increases by 30.9 percentage, around 31%, right? Whether it is a linear regression or a logistics regression, remember, whenever we are interpreting a categorical variable, it is always with a base level, baseline reference. It cannot have an absolute value like our continuous variables, right? So same thing, odds ratio, almost same what we discussed. Only thing is that it shows ratio with the baseline, right? Only thing what you have to remember here, this confidence interval, right? For some cases, if you see confidence interval is very low. Confidence interval low means our whatever prediction or our calculation is being more accurate, right? If confidence interval is high, it can vary. So the numbers or the whatever odds estimate we are giving, it can vary, right? With a lot of changes, right? So this number, if I see education illiterate versus unknown, right? If I go here and see that what is my point estimate, education illiterate versus unknown. Okay, it should be in the my previous slide. Education illiterate, unknown is the base parameter, illiterate is 1.591. So it has a very good odd estimate. What it says, if somebody is illiterate in comparison to somebody whose educational information is unknown, that person has a 59%, 59.1 percentage more odds of taking a bank account. But if I go here and see this confidence interval, odds ratio with 95% confidence limit, it has a very large confidence limit, confidence interval. What it shows that this number which I say 59.1, it lies somewhere in the center here, but it can go below certain limit and it can go up to very high limit, right? So this odds ratio can might change. So my odds ratio is around 1.591. It can become as low as 0.2 or 0.3, or it can become as high as 6 for some persons, right? So my estimate, what I'm telling, just imagine if I give a range that okay, how much Virat Kohli will score can be anywhere between 20 runs to 200 runs. Then how we are going to bet on that? Can you take that as a good confidence? Rather than saying that if I say that okay, his score will be somewhere between 80 to 120, that gives a good estimate, right? So apart from your odds, this, if you look back here, this shows that some person, let's say, who is a what else, illiterate, right? So that person opening a bank account is looks like more odds, more probable. But unfortunately, what happens for that odds For that odds ratio, your confidence limit is very high. So confidence interval is very high, right? So what it says that you are not able to pinpoint your odds ratio. You will not have a lot of confidence in that odds ratio, right? That's why apart from that estimate, you have to also look into your confidence limits, right? Is there any question or doubt on this? So in your those of you for whom that enterprise miner is working, if you are running the logistics regression, look into odds ratio also, right? In that chart, when that odds ratio comes, take and try to interpret that for which of the variables, for which of the categorical or continuous variables odds ratio is high. So lift and gain chart, this is not available. I'll not say it is not available because I'm not. So if you write code in SAS code, it will come, but it is available in the enterprise miner. I have shown you how to put that in the enterprise miner. If you go to the result section, you'll get some chart like this, right? Now the point is how to interpret this, lift and gain chart, right? Again, the information or the answers which you'll get will not match with mine because, like I said, I have changed some of the data points which are given to you, but the method or the process remains same. What does lift and gain chart says, right? See, why we're doing, what is our main motive of carrying out this kind of logistics regression or any kind of prediction? I have a marketing campaign of this 40,000. How many total observations is around 41188. In your case, it will be around 38,000 or 37,000. So in the data set I had taken, I have around 41,188 data points, right? Information about customers. Last year, I have run some marketing campaign. After running marketing campaign, so there are a lot of informations in that data set about their marital status, their job, their kind of how many seconds we contacted that person, right? In number of seconds, how many times that person has been contacted, right? Consumer price index, like that. So many variables are there. Obviously, consumer price index doesn't become a good predictor. That's why it has been removed from the model. But other predictors like education, job, marital status, age, right? They are becoming good predictors. Now, what happens if, let's say, I do not create a predictive model, right? I randomly carried out a marketing campaign to 40,000, 41,188 customers. Out of that, I got a response from 4,640 customers, right? So what is my success ratio? What is my success rate? Though I would have liked to get 100% success rate, no marketing campaign will have that much success rate, right? So my success rate was 11.26%, right? So if I do not have a predictive analytics team, so what will happen? This year also I'll run randomly to potential customers. Out of that also I might get maybe less than 11% or more than 11%. So it will be 10%, 12, 13 or maximum 15%, right? If I'm lucky this year, I'll get around 15% response, right? And like that, many companies do. Randomly they send emails, try to get new customers. If you see in a day, you might be getting 5, 6 calls from different banks per credit card and all those things. Those are nothing but marketing campaign, right? Though we do not see that, for each of the call, each of the kind of email, each of the SMS, they are spending something, right? It can be very small. Obviously, right now telecom charges have dropped down, internet charges have dropped down, but still there will be some cost. Let's say I have these 40,000 customers. Okay, for each of them, if I spend 25 rupees, right? So how much cost is happening? Around 10 lakhs I'm spending, right? For each of the customer, if I spend 25 rupees, 25 rupees in contacting that customer, because I'm paying to my call center executives, I'm paying to telecom charges, I'm paying to SMS packs, all those things. Minimum per customer 25 rupees I'm spending. Again, it can be much more than that. I'm just giving a simple example. 25 into 40,000, I'm spending around 10 lakhs in my marketing campaign, right? For this kind of marketing campaign. Out of that, how many people responded? 10%, around 4,600 people responded, right? This year also, let's say I am contacting 50,000 people, right? For 50,000 into 25, I will spend again 12.5 lakhs. So if I consider the same ratio, out of 50,000 people, maybe 6,000 or 7,000 will create account with me, right? Why you are doing this prediction? Rather than targeting those 50,000 customers, if I'm able to find out those customers who are much more probable to create an account with me if I'm able to connect with them, right? Rather than contacting with 50,000 customers, if I'm able to find out 5,000 or 10,000 or 20,000 customers, right? And out of those 20,000 customers, obviously 5,000 or 10,000 open an account. So my success rate will become 50%. So obviously it will never become 100%. So what we are trying to find out, can we predict those customers? Can we find out those 5,000, 10,000 customers who will be much more profitable for us? So imagine the scenario. If next year I go with this predictive analytics rather than targeting 50,000 customers for whom I would have spent 12.5 lakhs, I'm able to find out, let's say 10,000 customers, right? With a success rate of 25%. So what? How much money I'll spend? 10,000 multiplied by 12.5, around like how much? 1.25 lakhs. Sorry, 10,000 multiplied by 25 rupees, 2.5 lakhs I'll spend. And with that 2.5 lakhs, I'll be able to still open those 5,000 or 7,000 accounts. Rather than spending 12.5 lakhs, I'm only spending 2.5 lakhs, right? See the difference, see the benefit of this kind of predictive analytics. Unless you are able to show that, the management, why they will invest in any kind of analytics software? As long as you are able to show that, okay, if I run this software, if I have this kind of algorithm, I'm able to run this kind of model, and I'll be able to pinpoint, target these customers only, and your success ratio will increase. And that is where your lift and gain chart comes. And this is the most important of, and this is much more makes sense for a business guy, because he will not understand what is a classification area, what is classification error, what is a odds ratio. He is not at all interested in that. But if I'm able to show this at the end, right, and say that how my model is going to help that person with a simple example. If you go by with the random choice of customers without any predictive model, you are again going to spend 12.5 lakhs. But I am going to pinpoint to you only 10,000 customers where you will spend only 2.5 lakhs, but you are able to have a success rate of 50% or 40%, right? And this is where your predictive or this kind of chart helps, right? So lift is nothing but, so what is this 11.26%? Out of 41,188 customers, I have 4,640 customers who have opted for my marketing performance, right? This again you can calculate for the data set which I've given. Only the numbers will be different. So just out of those 38,000 data points, you see that how many customers have opted for that creating an account. One. So how many customers have said yes to creating an account, right? So that ratio by total number of customers will give you the baseline performance. So what does baseline performance means? Because this year with the data set, I have a success rate of 11.26%. If I randomly select customers to market my product or market my savings, whatever deposit, within some error, that much percentage of customers are going to create an account with us, right? So that is the meaning of this baseline performance. What does my lift says, or what does this gain chart or lift says? By creating this model, I will be able to identify top 5%. So depth 5 means top 5 percentile of your customers. 10 means top 10 percentile of your customers. I'm able to identify these top 5 percentiles of my customers where percentage response is becoming 49.43%, right? That means this is around 50, close to 50%, right? So in that observation, because this I have taken from the training data set, so there is around 1,236 observations, 1,236 customers I'm able to identify. If I send them my whatever offer, my call center executives talk to them, right? The success rate is 49.43%, right? And if I divide that with my baseline performance, that gives my the lift number, right? What it says, how much by using my prediction, by using my this predictive algorithm, how much lift in my success rate I am able to achieve. So my baseline success rate is 11.26 percentage, but by using this predictive model, I'm able to identify top 5 percentile. So again, for each depth, you will get a different lift value. So if you calculate, it will kill 4.38795. How you get this number? My overall response rate for that 5 percentage customers divided by my baseline percentage, that is 4.38. If I want to put it in a percentage terms, how much improvement in performance has happened, my baseline performance I will subtract from my for that percentile 49.43 minus 11.26 divided by 11.26, that is 338.79 percentage. So that is the improvement in performance which has happened, right? So now with this only, irrespective of what else is there in my other slides, only this slide I can go and talk to a business executive. If you give me a chance to run this predictive algorithm, if you allow me to buy this software, right? Obviously, software will cost 5 lakhs, but that you can recover within next 1 year only, because next year when I do this prediction, right, your success rate will be close to 50%, right? So rather than targeting all 50,000 customers, you can only target 10,000 customers with a 50% success rate, and with 10,000 customers, your uh, cost will be only 2.5 lakhs. With 50,000 customers, your cost would have been 12.5 lakhs, right? So I will save you 10 lakhs, and if you pay me money for this 5 lakhs of software, then you will anyhow you are going to save 5 lakhs, right? So this is how generally you have to talk to the business people. Otherwise, why will somebody invest in this analytics and all? Right, and this is why this is very much important for a business perspective, right? Other things statistically very much important, you will know which are the predictor as a data scientist or data analyst, those are much more important to you. But this lift and gain chart is much more important for a business perspective, because you can clearly say that why you are doing this algorithm or why you are running this analytics, right? Clear or any doubt on this?
Sir, I have one question.
Yeah.
Sir, you said that lift, it shows the improvement in performance. So can we also say that the lift chart, it will also show us that my success rate is increasing and by how much it is increasing?
From the baseline, how much improvement is happening, that is your gain, right? So it has
Yes,
improved
sir.
by 338%, right? Lift means if it is this ratio, how far I am jumping. So basically think about how much increase in your by how many ratios, by how many times your success rate is improving. Lift is basically kind of a ratio.
Okay, sir.
Gain is what you said. Gain is basically the how much percentage in improvement from your baseline. So what it says, if I just talk to, or if I just target this 5% of the top customers, which my model will identify 1236, my success rate will be 49.43%, right? Rather than targeting all 40,000 customers, if I'm able to target these 1236 customers, right? And I'm able to predict those customers, what will be their kind of qualification, whether they'll be illiterate or whatever, that educational age, all those things, your success rate will be 49.43%. If you do not use my model, your success rate will be 11.26%. So my model is performing better than your baseline model in the ratio of 4.38, right? For that top 5%. Again, for the top 10%, you will have a different lift value, right? How much percentage you are getting percentage cumulative response divided by again whatever baseline performance. So these are nothing but 5, 10, 15 are top 5% of your customers your model are able to predict. Top 10%, top 15%. As you go on till 100 becomes total customers, right? So total customers, obviously it is there already given 11.26, right? So this model is able to identify top 5%, 10%, 15%, 20% of the customers whom you should target. So accordingly, like business objective will be what will be the minimum success ratio, right? And then if they can only go for the top 5% of the targeted customers, or 10%, 15%, that is up to them. Clear?
Sir, do we use both the lift chart as well as the gain chart, or can we use any one as well?
Both are related. Both are related. Any one of them. So if you know the lift, obviously you know the gain from the baseline performance. Okay.
Sir, one more question, sir.
Yeah. Go on.
Sir, in depth 30, we can see that gain is shifting from 162 to 161. However, the lift, it is going from 1.29 to 2.57. So why is this happening, this change? So because over here in gain, we can see it is decreasing. Shouldn't that happen in the lift as well? Shouldn't
Yeah, I
it also
think
decrease?
just let me calculate what is 29.443 divided by 11.26. What will become? It is, yes, it is 2.57. Okay. So then why it is? I think these two values are little bit. Cumulative response is 33.27.
Sir, also it is happening again in, I guess, depth 70 also. The same thing is happening from 0.1 time.
Yes.
1 time
So
to
if you see
0.10.
for these two, where is this? So which one you told? 30, right?
Yes, sir, 30.
Yes. If you see, suddenly what happens? Percentage response has decreased. So in this particular two case, when I take top 20% customers, top 25% customers, what is my percentage response? 19.57. Here 14.57. Right. Only when I'm taking 30, suddenly it is increasing. Right, it is becoming 28.96% customer. That is where when I divide 28.96 divided by 11.26, my lift is improving, but my baseline remains same. So in the particular case, what happens? In this particular case, if I take the ratio of uh, what is my cumulative 29.54 divided by so just think about this 30%. What it says, if I take this 30% of my customers, right? What is my cumulative response rate? 29.443, right? 29.443 divided by 11.26. Whatever is that, 29.4 divided by 11.26. Can somebody quickly calculate? 29.4 divided by 11.26. How much it is come? Anyone? Quickly.
2.6.
2.61.
Where is this? 30, right? 2.61 minus 1, if you say, that will be 1.61 multiplied by 100. That will give you 161%. So what it says, for the top 30% customers, right? If I'm considering this top 30% customers only for my targeting campaign, my overall performance in comparison to baseline model is much more than by 161%, right? So that is there. But when I'm coming back to the lift, for this particular 25 to 30, right? What is my percentage of response? From the 25 percentage, sorry, top 25 percentage customer, from top 25 percentage customer to top 30 percentage customer, how much I have got the improvement in response? 28.96%. 28.96 I divided by 11.26. That will come back to close to this much, 2.57. So lift is for that particular 5%, 5%, 5%. When I'm talking about the gain, I'm considering all those 30%, up to 30% of my customers. But when I'm talking about the lift, from next 5%, how much improvement in my lift is happening? So if I calculate lift for this 30%, how much lift has happened? Percentage response is for that particular 5%, because this CPC bracket of 5% each, right? 28.96 if I divide by 11.26, it will be close to 2.61, sorry, 2.57. Just divide 28.96 divided by 28.9644 divided by 11.26. How much it is?
2.57. 2.57.
So these, so there is, and if you divide by 14.574 and divide by this 11.26, you'll get this value 1.29. because for that 5%, so when I say this 25, from top 25% to top 25%, how much lift has happened? So this is only how much? 14.57%. From top 25% to top 30%, how much lift has happened? 28.96. Ideally, that should not happen. Ideally, this kind of generally it keeps reducing. This is a like kind of little bit outlier type of information, but still the calculation will remain within that top 5%. How many customers you are able to successfully identify? Right, success means that creating an account with. Clear?
Yes, sir.
So that is about your lift and gain chart. That concludes your logistics regression, right? Any questions, any doubt what we have discussed so far? Anyhow, I've written the definitions here. Decile or demi-decile means 5%. Here, if you see 5%, 5% like that, the like kind of segregation has happened. You can do it for 10% also, right? Percentage response, cumulative percentage response, and this is where gain is. What is the gain in the percentage terms? Lift is the ratio of percentage captured response within each decile, right, to the baseline. Gain is the decile with that baseline reference is 11.26% for me. For you, it will be little bit different if you calculate. Our size we have discussed lift and gain chart. So this is a like